Dear students, in this video we are going to discuss about magnetic field lines, but before that we must know about magnetic field. Magnetic field means a field, a space where the effect of the magnet can be felt. Suppose you have a magnet here, so the space till where the effect of this magnet can be felt, can be experienced, will be known as magnetic field of a magnet. To visualize the concept of magnetic field, Faraday introduced the concept of magnetic field lines. Magnetic field lines are nothing but imaginary curves which tell us the direction of magnetic field at a particular point. Okay, so basically they are just imaginary curves which tell us the flow of magnetic force, right? So if you will draw the tangent to any of the point in a magnetic field line, that tangent will give you the immediate instantaneous direction of the magnetic field at a particular point. Suppose this xy is a magnetic field line, okay, and this is some point P, and a tangent is drawn to this point P. So this tangent is giving the direction of magnetic field at this point, okay. And secondly, basically, if you have a magnet somewhere and you keep a magnetic compass needle somewhere, so the direction of the magnetic compass needle will give you the magnetic field lines also. So basically, magnetic compass needles are aligning along a path, and that path is known as magnetic field line. Like this is a magnet, this is a magnetic compass needle, okay. So you need to see along what direction this compass needle is aligning. Suppose it is aligning towards here, so this will be the first point. After that you will keep it at this point only, and suppose this is aligning here, so this will be the second point. After that, if you will join all these points where the magnetic compass needle is aligning in total, then combining those points will give you the direction of magnetic field line, right? And then we have different sorts of magnetic field lines. We have different representations of different situations. So situation number one, first of all, what is a uniform magnetic field? Uniform magnetic field means a magnetic field which has the same strength everywhere, whose magnitude is same, absolutely the same everywhere, and it has the same direction at all the points in a region. I repeat, uniform magnetic field is something which has same strength and same direction everywhere at all the points in a region. If you want to represent uniform magnetic field which is lying here in this plane of paper, then you have to draw equally spaced lines. Those equally spaced lines will be representing you the uniform magnetic field. Had it been a uniform magnetic field directed inwards to the plane of paper, like the magnetic field which is having this direction, right, inwards to the plane of paper, then we draw the crosses to represent magnetic field. So these crosses actually represent a uniform magnetic field, but this magnetic field is not in the plane of paper, it is rather directed inwards to the plane of paper. Okay, so it's perpendicular, of course. Next is dots. So if you have dots, if you represent magnetic field by dots, that would mean you have a magnetic field, okay. This one is uniform, right? And this is directed outwards to the plane of paper. It's coming out of the plane of paper. Of course, it's perpendicular as well. Next is non-uniform magnetic field. Non-uniform magnetic field is the one which does not have same strength and same direction throughout. Its strength can vary within different points of space. So we represent non-uniform magnetic field by drawing unequally spaced lines. Like these lines were equally spaced when we wanted to represent a uniform magnetic field. But in a non-uniform magnetic field, the lines are not equally spaced. Remember that. And then you have these lines also. Now, these are diverging lines. The space where the lines are close, that proximity of magnetic field lines, the closeness of magnetic field lines is basically telling you that in that region, in that particular region, magnetic field is pretty strong. Okay, so you need to remember this, that if the magnetic field lines are dense somewhere, close somewhere, that would mean that the magnetic field is very strong there. Next is magnetic field due to a bar magnet, due to a magnetic dipole. We know that had it been an electric dipole consists of two charges, one positive and the other negative. The electric field lines go away from positive charge and they are directed towards the negative charge. Okay, so basically we know that these they do not form a closed loops. If they are originating from positive charge, they are not coming back to positive charge. Positive charge से वो हमेशा देखो अवे ही डायरेक्टेड हैं. अगर आप मैग्नेटिक फील्ड लाइंस ऑफ एन इलेक्ट्रिक डाइपोल को क्लोजली एनालाइज करोगे, यू विल सी दैट one direction is going here and the other is not coming back. It's also going there only. So they are originating from positive charge and ending up at negative charge or ending up at infinity. So electric field lines do not form closed loops. Loop नहीं बन रहा है यहाँ पे. But if you talk about a magnet, like if this is the magnet, right? Then the magnetic field lines of a magnet, they are like this. They form a closed loop. They originate from North Pole to then go to South Pole, and then inside the magnet the direction is opposite. Try to get it. So basically they form closed loops. Okay, and then we are going to study the magnetic field lines, the properties of magnetic field lines. Just a second. So property number one is, I have already told you that magnetic field lines form continuous loops, right? Unlike electric dipole, which does not form any continuous loop. Next concept is, outside the body of the magnetic field lines move from north to south, and inside the body of the magnetic field lines move from south to north. So what is the direction? North to south outside the magnet, and south to north inside the magnet. So this is basically the direction of magnetic field lines. So what was property number one? Magnetic field lines form continuous loops. Property number two, the magnetic field lines have the direction from north to south outside the magnet and from south to north inside the magnet. Next property, if you have a magnetic field line, okay, and you happen to choose this point to find the direction of magnetic field, then you just have to draw the tangent. The tangent to this point will give you the direction of magnetic field at this point. Remember that. So this is the next property. Once again, we are going to analyze the same fact of crowdedness of magnetic field lines. Basically, I told you people that if magnetic field lines are very crowded somewhere, so that would mean the intensity of magnetic field at that region, in that region, is very high. But when the magnetic field lines are widely separated from each other, they are somewhat spaced from each other, then the magnetic field has a low, less density over there, and you can expect the less magnetic field present over there, right? Next fact is, no two magnetic field lines can intersect each other. It is absolutely the same as you had studied that no electric field lines can intersect each other, because if the two magnetic field lines intersect each other, then at the point of intersection, two tangents can be drawn. One corresponding to this curve and the other corresponding to this curve. So if two tangents can be drawn, so this means there are two directions of magnetic field at one point only. Okay, there are two directions of magnetic field at one point only. But how is this possible? Okay, how can one point be attracted over this side also and attracted over this side also? So this is not possible. So always remember that magnetic field lines can never intersect each other. Remember that. Okay, so these are the properties of magnetic field lines, and this is all about magnetic field.